10.1, number 35, it says a projectile is going with initial velocity v sub 0 feet per second. Its path is given by the parametric equations right here. Find the length of the path traveled by the projectile. Alright, so here's what we have. We've got a projectile. It's launching at 20 degrees. This is 20 degrees right here, with an initial velocity of 150 feet per second. So we want to know, A, find the length of the path traveled by the projectile. So we want to know how far this is right here, not the horizontal distance right here. Like if this were a string and then you stretched it out, how long is that arc? Well, if we have parametric equations, then we can just use our formula where we integrate from a to b, square root of dx dt squared plus dy dt squared. Okay, so our x is equal to initial velocity times a cosine of 20, and our y, so anytime we want to find out what, times t. So anytime we want to know where it is in the x, the horizontal component, like if you plugged in t equal to 1 after 1 second, where is it horizontally? It would be 150 cosine of 20 units to the right. And then the y is our initial velocity sine of our angle t minus 16t squared. So if you want to know how high it is, after 1 second you plug 1 in for t, and that's how high up it's going to be at that point. Okay, so we want to know how far this traveled right here. So what do we know? We know it's time equal to 0 all the way equal to time equals whatever that is. We want to know what is the time at that point. Okay, what do we know at that point? We know that the y is equal to 0. Okay, our height is 0. So we can make y 0. And we can solve for t. Well, they both have t in them, so it's 15 sine 20 minus 16t set equal to 0, so t equals 0. Well, that's not surprising that y is equal to 0 and we've got a time t equal to 0. So right here, our y is 0 when t is 0. Okay, we knew that already. This will, when I set this equal to 0 and solve, that'll give us our other solution. So it looks like t is 15 sine of 20 over 16. That's how long it's going to take to get back down to the land. Okay, so 15 sine of 20 over 16. So in order to find the whole arc length, we have to integrate from 0 to 15 sine 20 over 16. That's our boundaries for time from 0 to this. That's what this is, that time. Square root of dx dt, which is just 150 cosine of 20 squared, plus dy dt, which is 150 sine 20 minus 32t squared dt. Okay, so I'm not very interested in evaluating that by hand, so I would just plug that into the calculator and you get your answer. So 461.75, and our units would be in feet. It's approximately. Okay, so that's how far the projectile traveled from here all the way to here. So that's part A. Part B, estimate the maximum height of the projectile. So how high up does it go? Well, it goes all the way till right there. Okay, and what do I know is going on there? That means that I have a horizontal tangent, so the rate of change vertically is 0. So I'm not going up or down, it's just 0 right there. So we can say for part B, when is dy dt equal to 0? Well, dy dt is, we already found it, I think. Well, it's in our formula right there. So it's 150 150 sine of 20 minus 32t, set that equal to 0. So 32t equals 150 sine 20, so t is 150 sine 20 over 32. So plug that into our calculator, make sure you're in degrees, and our time is approximately 1.603. Okay, we just found when it occurs. Okay, we reached the highest point after 1.603 seconds. But that did not tell us how high it went. We want to know how high it is. So we know the time, so we can just plug that into our y equation. Here are two equations right here. So y of 1.603, plug 1.603 in right here, and plug it in right there, and looks like I got 41.125 feet high. That's what y of 1.603 is, approximately 41.125 feet high.